Alright guys, here we are, section 1.3, polar and rectangular coordinates. So what you have to remember, what I started to talk about in class, is how going from rectangular, which is just our regular normal ordered pairs that we're used to in x comma y form, those are referred to as rectangular. The difference between that and polar, these are just different languages. Remember, polar uses r theta. R stands for the radius and theta stands for the degree of rotation. And so what we're going to do is work on translating back and forth from rectangular to polar and vice versa. It is just like doing a translation in English to Spanish or French to Chinese or whatever language that you're accustomed to doing translations with. That is what we're doing here in trig, okay? So what we have here is, don't forget that formulas and stuff that we've used from first semester. So this is Pythagorean Theorem, r squared equals x squared plus y squared. And then remember, tangent of theta equals y over x. And so the reason for that is that, remember, if we have a triangle like so, going back to unit circle days, this is the y value, this is the x value, this is the r value. And so remember, that's where x squared plus y squared equals r squared comes from. It's Pythagorean theorem with this right triangle. And tangent of theta, tangent is y over x. Okay? So that's just a little bit of recap for you. Another thing I want to draw your attention to is we're going to use these formulas a lot. This is going to be very helpful in our translation. And so what I can do here is I can cross multiply this and get x times 1 equals r cosine theta. And then same thing over here, what I can do is put this sine theta over 1 and I can get y equals r sine theta. So these are going to be really, really useful, these formulas for us. You already know that cosine is x over r. That's from first semester. You also already know that sine is y over r. So if we cross multiply those to get x and y by themselves, then I can translate any x value into polar language using r's and thetas. And I can translate any y value into polar language using r's and thetas. Those are a couple formulas that are going to help us when I practice converting. So when I do converting, what I'm going to do here is I have this ordered pair, but it's in r theta form. I need to translate it back to rectangular into the normal x, y that I'm used to. So remember those formulas that I have up above. I have x equals r cosine theta. Well, this is my r and this is my theta. So I just need to plug those in. Plug the 6 in here and plug the theta in there. Do the same thing for y. Y equals r sine theta. So what I'm going to do is I'm going to plug in the 6 for the r. I'm going to plug in the 7 pi over 6 for the theta. I'm going to do the same thing over here for y. And yeah, we can't forget unit circle stuff, just because that's going to come into play this semester also. The cosine of 7 pi over 6, remember that's in the third quadrant, and it's a 30-degree reference angle, so that's going to give us negative radical 3 over 2. And that's going to be negative 3 radical 3 for my x value. We'll do the same thing over here for y. Remember that 7 pi over 6, that's the same reference angle as it is over here, but that y value is actually negative 1/2. And so what that means is my answer in rectangular coordinates in terms of x comma y is, my x value is the negative 3 radical 3 and my y value is negative 3. And there's my final answer. And so remember what I used up here in order to convert from polar to rectangular is I used this stuff. What I'm going to do to convert rectangular back to polar is I'm going to use these. Okay, so I'm going to use that r squared equals x squared plus y squared, and I'm going to use that tangent of theta formula. Okay, so it's all above what I went through earlier, but that's how I'm going to use this, do this conversion part. So I'm going to start with x squared plus y squared equals r squared. I'm going to plug in my x value, and I'm going to square it, plug in my y value, and that's going to help me figure out what the r is. So this gives me 49/4, and 147/4. Remember how to square this. You're squaring the -7, which gives you 49. You're squaring the radical 3, which gives you 3. 49 times 3 is 147. That equals r squared. This equals 196/4, which is r squared, which when I square root both of them, I would have a plus or minus in algebra 2, but remember a radius can't be negative. There's just going to be 7. That's my radius, okay? So that's what the r is, and remember that's the first part of converting to polar. Now I need to figure out what this theta is, so I'm going to use the tangent. So tangent theta equals y/x, and remember we are given a y value and an x value. Our y value is that -7 radical 3/2, and the x value we're given is 7/2. When you flip and multiply and cross cancel and all that stuff, the 7/2 and the 7/2 cancel, and we just get negative radical 3. And remember, that's actually what the tangent of theta is. So I need to be thinking of my unit circle of where the tangent of theta equals negative radical 3. And so what I need to figure out is first, what quadrant am I in? And so one thing you need to notice about this is that that rectangular coordinate is a positive x value and a negative y value, and that is in quadrant 4. So I need to find the tangent of theta where negative radical 3 is in quadrant 4. So remember, that is a 60-degree reference angle, and so in quadrant 4, the 60-degree reference angle in radians, which is what the directions tell me to do up here, is 5π/3. So one thing that's a little bit harder about converting from rectangular to polar is that you need to first do the Pythagorean Theorem formula, and that was a little bit messy with fractions, but whatever. You have to also figure out what the theta is by using the tangent formula, and you have to go back to unit circle stuff. There are 2 places on the unit circle where the tangent of theta equals negative radical 3, quadrant 2 and quadrant 4. How do you know which answer to give? Go back up to your original problem. This is a positive x value and a negative y value, which puts me in quadrant 4. So therefore, my radian answer where the tangent of theta equals negative radical 3 is 5π/3. So my final answer, the way I'm going to write it in r theta form, equals, my radius was 7, my theta was 5π/3. So now what we have, you guys, is just a little bit of practice. I'm going to do a couple of these on this video, and then I'm going to save a couple of them to do as a class tomorrow as like a warm-up. So I'm going to start with this very first one. Convert from rectangular to polar. Remember that when your answer is in polar form, it should have r's and thetas. It's kind of like if I asked you to convert something from English to, I don't know, Spanish, if you're taking Spanish class, and you left some of the words in English, that wouldn't be correct, right? So you can't have any x's and y's if your answer is supposed to be in polar. So that's one thing to check for when you think you're finished. This very first one, y equals -3, and all I know about y is that it's equal to r sine theta. So I'm just going to replace y. I'm going to do a translation from what I put on the front page of y equals r sine theta. Now I no longer have x's and y's in my equation here, so that's good. What I can do here is divide both sides by sine theta. So I get r equals -3. This is actually cosecant theta. So now I no longer have x's and y's in my answer. I'm finished. Let's try the next one. X squared plus y squared equals 8y. I need to get rid of these x's and y's in order to convert it to polar. What I do know is that x squared plus y squared equals r squared. Okay, so that's a start. I got rid of some of the x's and y's, but I also know that y equals r sine theta. Okay. So what I'm going to do here is I'm going to divide both sides by r in order just to simplify. That cancels the r there, cancels the square there. So I get r equals 8 sine theta. Okay, just a couple more that I wanted to look at, going from polar to rectangular. So remember, if you're in rectangular form, you should have x's and y's. That means you should not have r's and thetas in your final answer. That's just one thing to be thinking of before you think you're finished. Okay, I'm going to show you a couple different strategies. These are, in my opinion, are a little bit more challenging, but one thing that you can do when you're given, remember that this is just r equals 6. Remember what we learned on the first day of polar, of what this actually looks like? What does a radius of 6 look like? It's a circle, right? With a radius of 6, everywhere on the circle, it's 6 away from the origin. And so one thing that you are allowed to do in order to convert these is square both sides. That's just one strategy. So there are multiple strategies, and I'll give you some more of them tomorrow in class, but one of the strategies is to square both sides. And that means, isn't r squared the same as x squared plus y squared? And now, oh my gosh, there's no more r's or there's no thetas. There never were any thetas, but I got rid of the r's in my equation and I replaced them with x's and y's. And again, if you really remember your stuff about Algebra 2, this is a circle equation with a radius of 6, but it's in x and y language. This is a circle with a radius of 6 in polar language. Okay, last problem I want to look at is this one. Again, what I'm trying to do is get rid of r's and thetas. And so what I think I'm going to try and do here is I'm going to change secant to 1 over cosine. This is, again, just a strategy, and this is kind of like doing those really annoying identities from last semester, is that sometimes if you try something and you can't figure out or you get stuck, you have to like scrap it and try something different. There's a lot of different strategies for these, and I'll continue talking more about this in class tomorrow. But at this point now, what if I cross multiply? I'm going to get r cosine theta equals 3. Wait a second, isn't r cosine theta the same thing as x? Snap. Now there's no more r's and thetas in my equation. So the goal of these conversions is to just kind of translate and get rid of, in this case, r's and thetas, and replace them with x's and y's. And there's a lot of different strategies that we're going to have to try and use on these. But let me just recap just these 4 problems that we did. This very first part was converting from rectangular to polar. And in this case, all I knew how to do was translate this y into r sine theta. And then I just manipulated it so that I could simplify it and get r by itself. In this case, I recognized right away x squared plus y squared equals r squared, but the problem with that is I still had a y over here. But again, I used the same thought that I did there as I replaced my y with r sine theta. And then I just have to simplify this, just normal algebra 2 rules. I had an r here and an r here, so I simplified, and that gave me r equals 8 sine theta. And again, before I think I'm finished, I'm checking my final answer to make sure there are no x's and y's present. That would be in the wrong language. And then down here, converting from polar to rectangular. When it's in rectangular form, you should only have x's and y's, no r's and thetas. So one strategy here is to square both sides. And so once I got my r squared, I recognized that as x squared and y squared. And again, hopefully you're making these connections between trig and algebra 2. R equals 6 is, if you look at your very, I think, first or second page of the notes packet, that is a circle with a radius of 6. And this is an algebra 2 circle with a radius of 6. Remember, in algebra 2, you were supposed to square root this number before you graphed it. Okay, and then the last one, r equals 3 secant theta. I just changed the secant theta into 1 over cosine theta, and then I was able to cross multiply there, and then I recognize r cos theta as x. This is similar to doing an identity problem. So a lot of the strategies and a lot of the mind exercises we did last semester are going to be really helpful this semester, okay? Thank you guys for watching. I will do these 4 problems in class tomorrow as a warm-up, and then we'll do some practice with all of you, okay? Have a great night.